So in this section, we're going to start talking about uh, error in the estimates that we're getting when we're using Taylor polynomials. Um, and this is a topic like all the others that we'll keep circling back to over and over again. This is just our introduction to it. So with this, we're going to be talking about three types of error. Truncation error in this video, alternating series error bound, and Lagrange error bound, or also what's called Lagrange remainder. So with truncation error, this is specifically used in geometric series. When we truncate a geometric series to get a finite approximation, what we throw away is our error. So this is why it's called a truncation error. What's been truncated is the error. Well, that truncation is an infinite geometric series that we can actually calculate the value of. So truncation error is actually a case where we can find our exact error, not just a bounded error. Bounded meaning that we say, hey, I don't know what my error is exactly, but it's less than, the absolute value of the error is less than this given value. But with truncation error, we can actually find the error exactly. And it's easiest to describe with an example. So we want to use the truncation error for f of x equals 1 over 1 minus x squared on the interval -1 to 1. And we're going to use a 6th degree polynomial to approximate f of 3/4. So remember that 1 over 1 minus x squared tells me my first term is 1, and my r is the x squared. So I have 1 plus x squared plus x to the 4th plus x to the 6th plus x to the 8th plus x to the 10th plus x to the 12th, and so on. Well, for a 6th degree polynomial, we're saying this is our approximation, which means that everything else is our truncation error. And if you notice, our truncation error is a geometric series where the first term, instead of being 1, is x to the 8th, and our r is still x squared, because it's using the same r as the geometric series that we use to get our polynomial. So that means that my truncation error is converging to my first term over 1 minus r. So when I do that, since we want to know what's the truncation error when I'm approximating f of 3/4, I plug 3/4 in for x. So I have 3/4 to the 8th over 1 minus 3/4 squared. And this is my error. For those of you who are interested in what that simplifies to about 0.229 for our error. Now notice, I didn't even figure out what did I approximate f of 3/4 to be using the polynomial, the 6th degree polynomial, because I wasn't asked for that. I was asked for the error, so I just went straight to the error. And this is kind of a key of one of the things you're going to see is a lot of times we're going to talk about the error without ever discussing the approximation, because we don't need to know the approximation to calculate error. And so a lot of times when you're asked about error, it's going to be a case of, hey, if it's a geometric series, we can do truncation error. Or if it's another type of series, like a power series or an alternating series, it's going to be one of our error bounds